Chapter 7, Proofing Quadrilaterals, Section 7.12, questions 15 through 20. Question 15, what is the relationship between the two triangles at the right? Create a flow chart to justify your conclusion. So we're looking at the right triangles. What's the relationship? So you can see the right angle, and then you can see the hypotenuse is 10, and then you can see one of its legs is 6. So it can't be congruent because the legs on the smaller one are 3 and 4. So if it's anything, it would have to be similar. So how do we prove that two triangles are similar? If we have an angle, which we do, which is a right angle, and we have sides that are in proportion, but we need not angle side side, we could do side side side, which means we'll have to use Pythagorean theorem to figure out the other side. Or if you know your triples, you know that's a 6, 8, 10 triangle or 3, 4, 5 triangles. If you didn't know that, that's fine. You can just use your Pythagorean theorem. 6 squared plus that distance of AB squared is equal to 10 squared, and then you could just you could figure it out that way. So 100 minus 36 would be 64. So when you take the square root of 64, you get 8. So if you don't know your Pythagorean triples, you can do that. And then now you can see that the side lengths would have to be in proportion for the triangles to be similar. So 3 over 6 would be 1/2, 4 over 8 would be 1/2, and 5 over 10 would be 1/2. So let's go ahead and create a flow chart to justify our conclusion. So I've created the flow chart showing that the three sides are in proportion, and that triangle JHG is similar to triangle CAB by side-side similarity. Question 16. The area of the trapezoid at the right is 56 centimeters squared. What is H? Show all of the work. So if you remember, the area of a trapezoid is 1/2 times the height times the sum of the bases. So if we know the area is 56, and we don't know the height, but we know base 1 and base 2 are 6 and 10, so that's 6 plus 10, then we can go ahead and solve for the height. So 1/2, 6 plus 10 is 16. So then we can say 56 is equal to 8h, divide by 8, and h is equal to 7. So that means that the height would be 7 centimeters. Question 17. Line L is perpendicular to line 6x minus y equals 7 and passes through the point 0, 6. So I'm just going to stop there and go ahead and graph that and see what that looks like. So line L is perpendicular. So if it's perpendicular, we need to figure out what the slope of this line is. So let's go 6x minus y equals 7. I'm going to solve for y. Since it's negative, I'm just going to add it over to the other side to get y plus 7. And then I will subtract the 7 to get 6x minus 7. So the slope of this line is 6. The slope perpendicular to that is negative 1/6. So it's perpendicular and it passes through the point 0, 6. So we know the slope is negative 1/6 and it passes through that point. So if I graph that, 0, 6, with a slope of down 1 to the right 6, I could also go up 1 and to the left 6. So this would be line L. Alright, line M is parallel to the line y equals 2/3 x minus 4. So if we got new line, y equals 2/3 x minus 4. So this has a slope of 2/3, and since it's parallel to that line, then a line that has that parallel has the same slope. So we know it has a slope of 2/3, and this one passes through the point -3, -1. So let's go ahead and graph that one. At -3, -1. So -3, -1. And the slope is 2/3, so up 2 to the right 3. And you'll notice it intersects line L. So then we'll graph this line. and that's line M. Where do these lines intersect? So they intersect right here. This will be 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5 up. Explain how you found your solution. Well, you can see how we found the solution, at least the way that I showed it, is by finding the equations of line L and M, graphing them, and then seeing where they intersect. We could also solve it if we knew what, I didn't write the two equations of the lines, but if we wrote the two equations, we could solve it as a system. Lots of different ways, but the intersection point will be at 6, 5. Question 18. Examine the geometric relationships in each of the diagrams below. For each one, write and solve an equation to find the value of the variable. Name any geometric property or conjecture that you used. Alright, so on part A, we see that these three angles are all congruent. It's saying that the whole angle is 3m minus 28. So this angle is m. That means this one is m and this one is m. So 3 times m would be the bigger angle, and that should be equal to 5m minus 28 degrees, which is also the bigger angle. We can solve that by subtracting 3m. So it would be 2m, add 28 to this side. So divide by 2. M is equal to 14 degrees. Alright, on part B, we have one angle is 3x plus 38, and another one is 7x minus 8. Looks like we have parallel lines, so if we take this parallel line and this one, and it's cut by this transversal, then those two angles are same side interior, which means they are equal to 180 degrees or supplementary. So we can write the equation as 3x plus 38 degrees plus 7x minus 8 degrees is equal to 180 degrees. Combine your like terms. That's 10x plus 30 degrees is equal to 180 degrees. Subtract 30 degrees. So 10x is equal to 150 degrees. Divide by 10. And x is equal to 15 degrees. And the geometric property that we used for that one was same side interior angles, two parallel lines cut by transversal, then same side interior angles are supplementary. Part C, triangle ABC below is equilateral. So if it's equilateral, we know that all of these side lengths have the same measure. If it's equilateral and you have that perpendicular, then this n plus 4 is half of the side length there. So what we could do is we could say that this other one over here is also n plus 4. So twice n plus 4 should equal one of the other side lengths, which is labeled 3n minus 1. And then we can distribute. Subtract 2n, add 1, so that'd be 9. If I subtract 2n, that's just n. So it looks like n is equal to 9 units. Part D. C is the center of a circle below. So we know C is the center. AB is 11x minus 1, so this whole length here, which would be the diameter. And CD, which would be the radius, is equal to 3x plus 2. And since they go through the center, that's going to help us identify the radius and the diameter that I just spoke of. So the radius is half the diameter. So we can write that 3x plus 12, since it's the radius, if we times it by 2, it'll give us the diameter of 11x minus 1. So 6x plus 24 is equal to 11x minus 1. Add 1 to both sides, we get 25. Subtract 6x. We get 5x, and then divide by 5. X is equal to 5 units. Question 19. In the shape factory, you created many shapes by rotating triangles about the midpoint of its sides. Remember that the midpoint is the point exactly halfway between the endpoints of a line segment. However, what if you rotate a trapezoid instead? So you can see the trapezoid over here in the graph. And it says, carefully draw the trapezoid above on graph paper. along with the given midpoints. Then rotate the trapezoid 180 degrees about one of the midpoints and examine the resulting shape formed by both trapezoids, so the original and its image. Continue this process with each of the other midpoints until you discover all the shapes that can be formed by a trapezoid and its image when rotated 180 degrees about the midpoint of one of its sides. So you're really going to do this 4 times, and you're going to see what happens on all 4 occasions. So you can do this using tracing paper, but what's going to happen is if you rotate it on either one of these non-base sides, what's going to form here, and it might not have it exact, but it'll look something like this. Alright, and so that's going to form a parallelogram. So if you do it from this point, if you do it from the other point, same thing's going to happen, except now you'll have it on this side and then like that. So remember, you're trying to see what that whole image brings, and that's going to be a parallelogram. So the non-base sides will create parallelograms. And then if you rotate on the base sides, this one, you'd rotate and trying to visualize, kind of looks like it'd go like this, and here, but you're going to end up having 6 sides. And then if you do it the other way, look more like this. So kind of look more like that. Still, once again, 6 sides are a hexagon. So those would be the 4 different ones. So 2 of them create parallelograms and the other 2 create hexagons. Question 20 on graph paper, plot the points A and B, which I've already done. Find length AB. So we can create a right triangle, and then we can use Pythagorean theorem to figure out what the length is. So we have, looks like 8 units on this side. That's the difference between your x values. And then we'll have 6 units on this side. If you know your Pythagorean triples, you'll notice that this is a 6, 8, 10 triangle. If not, you can use Pythagorean theorem to figure it out, but it will be 10 units. We want to locate the midpoint of AB and label it C. What are the coordinates of C? So one way you can find the midpoint is to kind of think of it as the average of the 2. And so we can take your x coordinates of -5 plus 3 and divide that by 2. Take your y coordinate 7 plus 1, divide that by 2, and that would give you -2 over 2 and 8 over 2. So -1 comma 4 right here, it looks like. That will be point C. And that's at -1 comma 4. And then on part C it says find AC. So now we want to find this distance for AC. But if it's the midpoint, as we just located here, then it should be 5 units. Can you do this without using Pythagorean theorem? Absolutely. Because if it's the midpoint, then once again, this should represent 5 units. This right here is 3, 4, so it will be a special right triangle, but because it is the midpoint, we do know it's half of that. So once again, either way is fine, but it would be 5 units.